previous tutorial, we learned how to draw excitation diagrams. So in this tutorial, we are going to use this excitation diagram to draw a series of sequence. So in production, we use this excitation diagram to come about developing a series or sequence that a factory can use in production. So it's like a system. Maybe in stage 1, if maybe a drink production industry, maybe stage 1, the bottles come to a button. Stage 2, it moves to the stage 2. Maybe the machine puts the cover on it. Stage 3, and package it. So it depends on how you design your series of sequence. So in a sequential order, the factory manager can ask you to design it. So I'll help you to use this excitation diagram to design a series, simple circuit or a simple diagram, a simple appliance that can work like that. So probably we are given a problem to solve. In the factory, we are asked to solve a problem as you designing a series of sequence that can have 4 stages. So in each stages, given like this, first stage we are having a bit of 1, 0, 0. Second stage we are having a bit of 1, 1, 0. From 1, 1, 0 we are going to 1, 1, 1. From 1, 1, 1 we are going to 0, 0, 0. From 0, 0, 0 we come back to this. So this is the problem. You are being given this by the factory manager to design a system that from stage 1 it goes here, from here to here, and it's done. It's already done. It's ready for packaging. So with this problem, you'll be using to draw a truth table. Because we are having 3 bits, we are going to draw 3 flip-flops. So it goes like this. We are having a present in next stage. We are having our present state. Yeah. Our next state. Yeah. And this stage is JK. So J not K. So let's say these are the flip-flops. Flip-flop not, flip-flop 1, flip-flop 2. Okay. So from our flip-flops, which 0, 0, 0. So from our flip-flops, we'll be having our JK, J0, K0, J1, K1, J2, K2. Okay, so we have this diagram. This is our truth table. So with our truth table, we can have our input as Q0, Q1, and Q2. Here to Q0, Q1, and Q2. So our first stage is 1, 0, 0. Next stage is what? 1, 1, 0. 1, 1, 0 will be repeated here. Our next stage is 1, 1, 1. Our 1, 1, 1 will be repeated here again. Our next stage is 0, 0, 0, 0, 0. 0, 0, 0 will be repeated here. And our next stage is 1, 0, 0. Okay, so this is basically our truth table. Let me wipe out this stage diagram so we can get enough space. Okay, so this is the time that we can use the excitation table. So how would this excitation table help us in designing? So this is where we got into. We are having our present stage and our next stage. So our flip-flops, how to get a JK, is being decided with the excitation diagram. So first one, when drawing for not, we are having a not, Q0 and Q0 as our input. So you consider 0, 0. Coming here, 0, 0 is what? 0x. So you write your 0x here. Consider 0, 1. 0, 1x, 1x. have your 1x. Consider 1 0. 1 0 is what? X1. Write your x1. Consider 0 0. 0 0 is here again. 0x. 0x. Very simple. So our next stage is J1 and K1. So you consider this side, the 1 1 side. So you have 0 1. 0 1 is 1x. 1 in x. So we are having 1 1. 1 1 is x0. x0. So you have to look. This is what is going to help you to draw your truth table accurately. So from the truth table, you are going to draw your K map. Okay. So when you have this table wrongly, you have a K map as also wrong, totally wrong. And when you are circuit you are designing, you are having a problem, a mistakes. Okay. So continuing, you are having 1 0. This 1 0 is x1. x1. You are having 0 0. 0 0 is 0x. 0x. Okay. So we are at J2, K2, flip-flop 2. We are using the 2 2 ranges. So 1 1. 1 1 is having x0. That's x0. 1 1 is having x0. We are having our 1 0. 1 0 is x1. x1. And our 0 1. Our 0 1 is 1x. 1x. Good. So we are done with drawing our truth table. Okay? So if you didn't get it, go back slowly and play it slowly. So we are going to draw our K map to design our series of sequence. So in designing a K map, you have to design a separate K map for J. Separate K map for J, K. J1, K1, J2, and J2. So in designing the K map for J dot, K map for J naught, so this is our J naught. You draw your K map here. In our other tutorial, we learned how to draw a K map, our K map. We are having the same here. We are having our Q0 here, Q2 and Q1. Q0 here, Q2 and Q1. We have to divide here, 4. 1, 2, 3, 4. We are having our 0 and 1. Okay? Drawing it, we learned it in our previous tutorial. So when you don't get it, you play back our previous tutorial. Having our 0 0, 0 1, 1 1, and 1 0. So we go back to our J. We are drawing our J naught. So our J naught is taken here. So the first J naught is 0. So 0 is 1 0 0. You come here, look for your 1. From the 2, Q2, look for this Q2. So 1 0 0 1 is here, but you are not having 0 0. 1 is here, you're having 0, you're having 0. So it meets here, so it's 0. This center is 0. So our next one is 1 1 0. 1 1 0 must be 1. So 1 1 0 is here, it must be 1. You're having our 1 1 1 is x. 1 1 1 is x. X is don't care. X is considered as don't care. So we're having 0 0 0 as 0. 0 0 0 as 0. So in mapping or in grouping this, when you don't need the x, don't use the x. The zeros are not considered. Okay? So we map it like this. We map it. In mapping this K map, you can map 1, 2, 4, 8, 16, 32. You can't map 3. You can't map 0. You don't map 0. You don't map 5. You get it? So here we can map this 1. We can map this. Don't care. We can map 2. With a don't care. So we can map it like this. Having our equation as Q2, Q1, Q2, Q1. So therefore J naught is equal to Q